Hello dear students, today I will discuss about Euler's method for solving numerical solution, numerically the differential equation, Euler's method and then Euler's modified method. Okay, just in the previous class we have already seen the Picard's method and Taylor's method, Taylor series method. So here Euler's method. Okay, Euler's method for numerical solution of the first order differential equation initial value problem. Okay, so here just suppose this is our equation dy upon dx equals to fxy and condition y equals to y0 at x equals to x0. This is our problem. Okay, just we have to solve this, that is we have to find the value of y which will satisfy this initial value problem, means initially given this condition for this differential equation, just we have to solve this differential equation. That means we have to find the value of y, okay, by Euler's method. Here Euler's method, formula for Euler's method, we use tangent at a point on the curve. Now see what is this method, because what will be the formula for this method. So here generally its solution means what? The relation between y is equals to some function, y is equals to some function, because after solving, if we solve this differential equation analytically, then we can solve this. If this format is of our standard format, then we can solve this analytically and we can find also constant value by using this condition. Then we can get a relation between y and x, that is y equal to some function of x. This is what? The simple relation. It can be graphically plotted because it represents a curve. That is, if we draw the curve from this equation, that will be the curve of solution. This is solution, and if we draw the graph, then that will be the curve of solution. Curve of solution. We can say that this is solution and curve of solution. Both are same. This is algebraically or this is graphically. Okay. So curve of solution means what? Here for any value of x, for x equals to suppose 1, you can get the value. For x equals to a, we can get the value by using this. For x equals to 1, the value of y, what we get, that will be a point. The value of x, value of y. Here also a, value of y, be a point. All these points lie on this curve. Clear? Now, if also initial condition is this, that value is also on this curve. That value is also on this curve. Just for finding the value of y for a particular value of for a particular value of x equals to suppose a. That means the value of x0 is different value. X equal to a will be anywhere. That is, the starting value is x0 and our targeted value for which we have to find the value of y, that is a. And this is the interval. That means at this value, the value of y, that is, this is a and value of y. Value of y. Just we have to find the value of y. Clear? So just we are trying to find this value for this targeted value. This is our main technique for finding value graphically. So here use Euler's method is tangent. Means by using tangent, just we have to approximate the curve of solution, because solution of this means curve of solution, we can say in other words, because suppose this is y-axis, this is x-axis. Y-axis means value of y, the value of y lie on this. Okay, now like this. Origin, this is origin. Clear? And here for this method, just we will discuss by taking graphical approximation. Okay. Curve of solution means its solution. Okay, the initial point is x0, y0. Suppose this is x0, this is x0, and y0 is this here. Suppose this value is y0. Okay, this value is what? Y0. That means this point is what? X0, Y0. Clear? This point is. So you can write X0, Y0. This is point. First point. Suppose this point is P. Now our curve of solution, that is this initial condition. So this is also on the curve. So our curve start from here. Okay. Now our targeted value is, suppose our targeted value is just for initial value is x0 and our targeted value is suppose x n. Suppose then this interval means targeted value is anywhere on this line. Suppose our targeted value is this. Okay, x and clear. Now this interval x0 to xn, just we have to divide this interval, because here this distance is divided in sub interval just like this, and in each interval equal length, equally we have to divide. Or suppose interval is h, and in this part, because our curve is just like this. Now if we divide this interval in short, and equally in n parts, suppose in general, suppose n parts. Okay, 2 parts, 3 parts, 5 parts maybe. Now as this interval, this subdivision is very simple, very small, then in this part the curve may be treated as a straight line. That's why since from x0 y0 curve pass, so in this interval, suppose like this, then this in this interval we can suppose we can approximate this part just like this curve, this part we can suppose a tangent, means tangent may be used to approximate the curve if this interval is less than tending to 0, is very less. So that is the main point of this method. Just in this interval we are approximate the curve in each interval by tangent, that is this line and then this line and then this line and then this line. By using this approximation by small arcs that are tangents, and if our targeted value at this, for this value of x, the value of y is here, then we can go to that part by taking tangent, tangent, tangent and so on. Okay, so suppose here tangent is this is point x0 plus, if this is interval h, then x0 plus h, then this is x0 plus 2h, this is x0 plus 3h and so on, this is x0 plus nh, this is equals to, in this part p1, this is tangent to the curve, and also in this part if we take tangent, then this will be just like this, and in this part if take tangent, and this part will be like this. Okay, here. And similarly, at the last stage, and this value is with what? This value will be what? This is x0. So x0 plus h, this is x0, this is x1, this is x2, this is x3 and this is xn. So here this value means what? x1, y1. This y1 can be found by using tangent, because this is tangent at the curve. So finally we can get a tangent like this, or here y equals to y0 at x equals to x0. Okay. Finally, this will be the value q, and this will be the value y, and this will be the final value for our targeted value, because this, that is the value, because our tangent this on this is this is the curve of solution. Curve of solution, actual. Okay. And tangent may be used to approximate this curve at each stage. Here we will divide x0 to xn in n parts. In each parts, if h is very small, then tangent may be used to approximate the curve of solution. So from the equation of tangent at point this is intersecting here, means this is tangent to the curve, and this point P1 is lie on the tangent. So y1 can be found from this tangent. So tangent, how can we find the tangent? Just use the equation of line passing through point x0, y0 and having slope. What will be the slope? This. If this is theta and P1, suppose this value is R. This is x-axis, this is parallel to x-axis, this is line, the slope tan theta. So from here, in triangle P1 R, tan theta equals to perpendicular by base, this by this. So P1 R by PR. Clear? This is angle, this is perpendicular. So P1R by PR. Clear? We can use this R1 also, R1. Clear? So from here we can find P1R equals to PR1 tan theta. P1R, this value. And this value is what? This value plus this value. So this is what? Y0. This is what? Y0. Y0 plus this, P1R. So this is Y1, total value. This is Y1. So Y1 equals to what? Y0 plus this. So Y1 equals to Y0 plus P1R. So Y1 is equals to Y0 plus P1R means what? PR1 tan theta. And this Y1 equals to Y0 plus PR1. This value is what? This value. H. X1 minus X0. Okay, so this is X minus X1 minus X0. And tan theta, slope of the tangent. And slope is given by dy by dx. So, dy upon dx at this point, x0, y0. So, at x0, y0. So, from here, we see that y1 equals to y0 plus x1 minus x0 f x0 y0. F x0 y0 y, because dy by dx is equal to fxy. dy by dx at x0 y0 fx0 y0. fx0 y0. And x1 minus x0, that is this minus x0, h, this h. So finally our value of this y1, because this y1 is finding from this condition, that is from tangent. Just we can use here h f x0 y0. This is our first approximation of y by using tangent. You can see also by using tangent, formula of equation of tangent. Just how can we write the equation of a line passing through a point and slope having slope m? If this is angle theta in slope, now we know y minus y1 equals to slope x minus x1. This is the equation of a line passing through the point x1 y1 and having slope m. For this tangent, point is x0 y0. So this is y0, this is x0 for this point. And slope is what? Slope y minus y0, slope. What is slope? Derivatives. So dy by dx at what? At the point x0 y0 into x minus x0. This is the equation of y minus y0 equals to, this means from given equation, what? fx0 y0 into x minus x0. And this is the equation of tangent at this point. This tangent passing through this point P1, x1, y1, that is x1, y1 will satisfy this tangent. So we can put here y1 minus y0. In place of x and y, we can put x1, y1 because tangent is this. So y1 minus y0 equals to here x1 minus x0 fx0 y0. So from here y1 equals to this approximation. y1 is equals to what? Transfer y0 here, right hand side, x1 minus x0. x1 minus x0 is equals to what? H. And fx0 y0. So this is our first approximation. Clear? And here h equals to what? Step. Equal intervals. Divide in n parts. Divide in 2 parts, 3 parts, 4 parts, 5 parts. How can we get the value of h? If interval just like this, suppose 1 to 5, 6. Then how can we find the value of n? How many steps are there in the h? Because last value will be what? x0 plus nh minus x0. Just total interval length divided by how many parts? N parts. So this cancel, n and cancel, h can be get. So for dividing an interval, what is the meaning of interval? Initial value x0, and if our targeted value is here x5, then just this interval divide x5 minus x0 upon, if 4 parts, if 3 parts, 2 parts, how many parts? Just we have to take. Suppose 3 parts, then this will be the value of h. Just like 0 to 4 and dividing 4 parts. Then 4 minus 0 upon 4 equals to 1. So h equals to 1. Okay. So by this formula, we have to find the value of h. So, and x0, y0 is given. So x0, y0 function is also given. H is Get? So y1 can be found. So very simple. Math formula is very simple in Euler's method. But there is the problem is this, that for more accuracy, h should be very small. But if we take h as very small, then the step will be increases and calculation work will be very tedious. So this is the drawback of this formula. Okay. So here we also modify this formula. There is modified Euler formula. For that modified Euler formula, just we use tangent also, equation of tangent also, but in each interval, just we purify, modify the value of y1. Just here we can see that if this is tangent, then if y1 come to here, that is nearer to curve. So for that, we can take in this step average of, because in this Euler method, this is the first approximation. For second approximation, just do the same process at this point. Also here take tangent. This will be the value of what? y2. This is what? x2, y2 at this point. y2 can be found by this tangent. Its slope is another value will be another value theta 1, suppose. Now, if we take average of this slope, then we can take tangents through this line, this point, using the average of the slope. Then our approximation will go fast to the curve. That is the Euler modified formula. So just I will discuss about Euler's modified formula after doing questions from this Euler's method. Here, just doing this process in Euler's method, just do this process step by step at this point, also at this point, also here take this, also here this point, and we will get the point Q. That is our targeted value. So step by step. The second step will be what? Here if y2 equals to here y1, because now we do same process at this point. So in place of x0, y0, x1, y1 will be used. So here y2 equals to here y1 h f x1 y1. y1 comes from here. Similarly, y3 equals to y2 plus h f x2 y2, and so on. Up to nth stage, we can get n minus 1 plus h f x n minus 1 y n minus 1. This is our formula, Euler's formula. Okay, this is our Euler's formula. Clear? By using this, just we will try to get the accurate value at Q, at Xn. Okay? Now take the questions here. Just we have to try to find the value of y more accurate. For that, our interval should be, the length of interval should be very small. Okay. So take the questions for by using this Euler's method, we have to solve, we have to approximate. This is our approximation. This is original initial value, first approximation y1, second y2, third y3, up to the targeted value. By dividing this interval, we have to decide how many stages are there. Okay. So Euler's formula used tangent. Okay. And modified Euler formula also the further steps. Here, just given dy by dx equals to y minus x by y plus x. Solution. Given differential equation is dy upon dx equals to y minus x upon y plus x. And given, what is given? Given is, given this with initial condition y equal to 1 at x equal to 0, y equals to 1 at x equals to 0. This is our initial condition. This is our initial condition. That is y equal to 1, x equal to x0. This is x0. This is x0 and this is what? Y0. Okay? And find y for x equals to 0.1 by Euler's method taking 5 steps. So how many steps are taking? Just it's depend on us. But if in the given question it is given that 5 steps, taking 5 number of n equals to 5. So we can find the h equals to. Okay. So we have to find the value of y for x equals to 0.1 taking 5 steps. 5 steps means n equals to 5. Clear? So h can be found. The initial value is x0 and targeted value is 0.1. That is n equals to what? 5. Therefore, h equals to, what will be the value of h? Targeted value minus initial value. 0.1 or x minus x0, that is 0.1 minus 0 upon n, that is 5. So this is equals to 0.02. 0.02. So s equals to 0.02. h equals to 0.02. Okay. h equals to 0.02. We can find like this. 0.1 minus 0 by this. Okay. So very simple method is this, because in the Euler's formula we know what is the formula. Very simple formula is there. Euler formula is Euler's formula is yn equals to yn minus 1 plus h f of x n minus 1 y n minus 1. This is Euler formula. Clear? So here how many steps are there? 5 steps. So first value is for from start 0.02, 0.02, 0.4, 0.06. Just we have to find the value 2, 4, 6, 8. This one stage, this is first stage, this is second stage, this is third stage, fourth stage, fifth stage. So just we have to find, because at this point value is given. So for this, for this, for this, for this, and for this, we have to find the value. That is first x1, x2, x3, x4, x5. Clear? So one by one we have to, the first approximation of y at x1 equals to what? This. This is x0, x1, x2, x3, x4, x5. Just we have to find the value at here, at here, at here, at here, at here. This final value at point 1. Clear? So now, the first approximation of y at their interval, just like diagram. This is 0, 0.1, 0.02, this 0.04, this and this and this, 4, 4, 6, 8, and this is 0.1. So this is our targeted value. So in this interval, if there is given value is 1, this is 1, this is y0, this is x0. So this, then this, then this, then this, then this. This is value. So first stage, second, third, fourth, and we get the value finally. In first stage, using this formula. So first approximation for the value of what? At x1. First approximation. x1 equals to what? 0.02. Clear? But with the value of y1 equals to y0 plus h f x0 y0. Here fxy equals to this y minus x upon y plus x. Here fxy equals to y minus x upon y plus x. Clear? So first approximation y0 means what? 1 plus h equals to 0.02, and fx0 y0 means what? y0 minus x0 upon y0 plus x0. This. So this can be solved just like this. 0.02 y0, this minus this. y0 means 1 minus 0 upon 1 plus 0. Just solve it. Okay, 1 plus here just 1.02. This is equals to 1.02. This first approximation. First approximation. Point 1.02. Second, third, fourth, fifth, and similarly just you have to do. Okay. Second approximation. Second approximation of y at, now just next test, just at x2, this x2, point at x2 equals to 0.04. Again formula y2. So y2 is equals to what? y1. y2 equals to y1. From this formula you can see that if 2, here 1. So y1 plus h f x1 y1 implies y2 equals to y1 plus h y1 minus x1, because this is formula y minus x upon y plus x, y1 plus x1. Just put the value. Here x1 equals to what? This. And y1 equals to this. And just put value here. y1. What? 1.02. This value. 1.02. Plus h equals to 0.02. So 0.02. Clear? And this. y1 minus x1. y1 is this minus x1 is this. So 1.02 minus x1 means 0.02 upon 1.02 plus 0.02. Clear? This is the approximation. Okay. Now solve it. Okay. Just use calculator. This minus this, that is what? 1 upon 1.04, and divide it and multiply it and add to it. Here we can get approximation y2 equals to what? Just like 1.0392. 1.0392. So this is second approximation y2 of the value of y for this problem. Okay, at this stage, just we have to go at the stage 0.1, that is here. So y3, y4, y5, just you have to find by using this formula and using successive values. Just for y2 we use this value and this value. Now for y3 we use this value and this value. Okay. Similarly, third approximation, fourth approximation you can write. So just in the different stage, we will get y1 equals to 1.02, y2 equals to what? 1.0392. 1.0392. Now we will get like the y3 and y4 and y5. Just approximate. Third approximation. Of y. Third approximation of y at just similar process, right? Here, what? At x3 equals to what? 0.06. y3 equals to y2 plus h of f of x2 y2. Just use this y3 equals to y2. y2 means just we get like this 1.0392 plus h 0.02. This is y2 minus x2. y2 means what? This 1.0392 minus x2. x2 means not this previous value. 0.04 upon 1.0392 plus 0.4 this. Just calculate it, you can get the value of y3. Subtract and add and divide and this multiply and this add by using calculator, you can get the value. Third approximation, 1.0577. 1.0577. That is 1.0577. This is third approximation. Fourth approximation. Fourth approximation of y at x equals to what? x3, 4 equals to 0.08. 0.08. y4 equals to what? Just using this formula, you can proceed. y4 equals to what? y3 plus h f of x3 y3, that is y3 equals to just getting value this 1.0577. 1.0577 plus 0.02 of this value y3 minus x3, this use formula used, just this 1.0577 minus x3, that is this value 0.06 upon 1.0577 plus 0.06 this way. Just calculate it, you can get the value 1.0756. 1.0756 y4 equals to, that is 1.0756. Clear? And the next approximation, next value, fifth approximation. Because just 5 steps are taking, so up to this steps. Fifth approximation of y at x equals 5 equals to 0.01. 0.01, not 0.1. 0.1. This. y5 equals to y4 plus h f x 4 y4. So this is equals to y4 means this value 1.0756 plus 0.02 and 1 point, because y4 minus ix, x4, y4 equals to 1.0756 minus point this 0.8. 1.0756 plus 0.8. Just calculate it. You can get the value as 1.0928. 1.0928 up to 4 places of decimal. Okay, just taking 5 steps, we get value like this. We can take 10 steps, 15 steps, 20 steps, then our result will more accurate. But if we take more steps, then calculation will be very tedious. So this is very simple method, very easily method, but calculation will be lengthy. Okay, it can be computerized, so but due to this drawback, there is a modification to this method, Euler's method, that is modified Euler method. Okay, so just now we will discuss about modified Euler's method. Finally, our answer is at here. Fine. Hence, this is y5. Our answer is hence the value of y using Euler's formula is 1.0928 at x equals to 0.1. So this is answer. Y equals to 1.0928 at x equal to 0.1 by Euler's method. Okay. Now I will discuss about modified Euler's method. Okay. Then next method is modified Euler's method. Just we have discussed about Euler's method. In the Euler's method, we are dividing the interval. That means if initial value for the function if initial value is y0 and x equals to x0, function is y, that is dy by dx equals to f xy. This is our initial value problem, and initial value for the y is y0, and if this is corresponding to this value, initial value of y is given, and our target is for finding value of y for a particular value of x n. Here is x n. Now this interval is divided by in many parts of equal parts, that is h, and h must be small value. If we take h is very small, then our calculation step will be lengthy. To overcome this situation, just there is modified Euler formula is provided, and just like theoretical process in Euler's method, we know if this is x0 and this is corresponding value of y0, this value is clear. This is y0, that is this point is what, x0 y0. This is our value. Just we have discussed in the previous method, we are trying to find the value of y for targeted value. Suppose this is xn. Just for this value of x0, the value of function y is y0, it is given, initial value, and for this particular value of x, for x equal to xn, we have to find the value of yn. That will be our accurate value. For going to that point, because curve of solution will pass through the point xn, yn. So for going to the target point, just we use in Euler's method what? Here tangent to the curve, and just if we divide this x1 and then x2 and then etc. up to xn. Here if tangent cross, in this part if tangent cross at here, and here this point is what? x1 y1. This y1 is find from the equation of tangent, and that is the Euler's method. And step by step, just tangent at here with slope this is the angle theta, and just here tangent is this is what? x2 y2. y2 is find from this tangent, and so on. We have to finally get point like this here. This is value of y1. Clear? And this Euler method. And now in modified Euler's method, in this method we draw tangent at x0 y0 which lie on the curve, and at the next point again we find the equation of tangent whose slope is what? By using this angle. Now equation of tangent through this point would slope this. Okay, but for getting better approximation, because just like this, finally here this is tangent, so curve in this interval we approximate curve by this tangent, and also at this point and this interval curve is approximated by this point and this tangent. So our main point is curve is just like suppose this, so we can finally get like this type of tangent. This tangent can be found. This tangent can be found by taking average slope. This is your point. This is our actual curve. Here. This is point, targeted point Q. Suppose this point is P, this point is P1, and this point is P2, and just here Q on this Pn is equals to Q. Q means intersection of curve through this ordinate. So that is the actual value for xn of yn. Okay, for this xn, the actual value of yn at here. This is a curve. But for approximation to this curve, we can get that point by this tangent. And this tangent can be found how? First tangent is this, second tangent is this. Here slope like this, like this. Now take average of this slope. For finding value at here, take average of this slope. Slope at here and slope at here. We can sum it. Because our equation is what? dy by dx equals to f xy, and y equals to y0 and x equals to x0. This is our equation. Initial value problem. So initial point is this, lie on the curve of solution. Now dy by dx equal to fxy, that is slope at this point. That means here slope of this tangent is fx 0 y0, fx 0 y0. What is this? Slope of this tangent. Slope of this tangent is this. Here also slope of the tangent will be what? fxy at point x1 y1. x1 just we will create this point by dividing in some parts. So at this point x1 y1 is getting from what? From this tangent. From this tangent y1 is getting. So this is the point x1 y1. At this point dy by dx equals to what? Yes, x1 y1. x1 y1. So this slope at this point of tangent. Now if we take average of these two, then this is tangent, and average of these two slope. By taking this slope, we draw tangent at here like this. By taking this slope, we draw tangent here, we get this. Now, by taking average of this slope, just like suppose we are having 30 degree, we are having 60 degree. Then 30 and 60, 30 plus 60 by 2, what? 45 degree. So in between we will get tangent. So here just we can draw the slope tangent through this point using this slope. By this new slope we can get our approximation, that is our tangent, to nearer to this tangent. Okay, suppose at here, at this point, this is tangent, this tangent, and here this is tangent. This to tangent, and by taking average, our line will be where? In middle of this. That is this tangent and this tangent. This tangent will be, because not here, sorry, here, because by taking average slope, with that slope we will draw tangent through here. That means from here we can draw just like parallel to this line. Clear? Means just we can suppose this type of method. Here this is slope, first slope, this is second slope, taking average of this slope, and at this point, at this level, just from here we can draw line with slope this, then that line will be just nearer to this line, and do this process repeatedly. By drawing this line, by drawing this tangents, by getting equation of this tangent with new slope, we can get the new value of y. We can get new value of y by using previous value of y, because here we know y1 equals to y0 plus h into fx0 y0. For getting new value, just previous value of y is used. Here, first value, initial value given. Just using this tangent, we get y1. And now by taking average of these two, we can get a new tangent. We can get a new tangent. Clear? From in between this new tangent. We can get the approximation of y1 again by modified slope, by modified formula, where this is what slope. In this place, just we take this slope, mean slope, and by taking previous value of y, previous value of y means just y1 1. This is approximation purify of the value y 1 by taking here what? First approximation we have to find from Euler's formula. So y0 this. And second approximation, for this y, second approximation, we can take average of its slope and by using new value, because in this formula just we see that average of this slope, and for the next stage just we will use here this plus here y1 1. Just use repeatedly the previous value of y and take new slope and use this here, and you can get approximation of y1 1 by 1 2, then y1 3. These are the approximation of just y1 is purified by taking average of slope and using in equation of tangents, we get new values. That is closed just like this, and once again doing this just like this, and again doing this just like this, and finally we can get the parallel line, the line parallel to here, and we can get approximate value. Okay? At this stage. So this in this interval, just we have to do a step by step by getting values of y1, first approximation, second approximation, third approximation in this interval, and purify the value y1. So finally, whenever two approximation give equal value, that will be the final value of y1. Okay, that is the final value for y1 for x1. Same process is applied for this interval also. Formula is changed as how? First stage, use Euler's formula for finding first approximation y2 1. Euler's formula. Euler's formula means just take first value. For this interval, first value is this, and y1 is getting from previous interval. That is here y1 plus h. Here fx for this point x1. Here y1 previous value of y. Okay, just like this. And this is first approximation. Now for second approximation of y2 for here. For second approximation, just take average of previous slope and here previous slope is this what? F x1 y1 plus f here 0 0 here x 1 y1 1. This is just take previous value, this value here, second approximation here y 1 2 2 here 1 2 this sorry y2 1 and then y2 2 and so on. We can get the approximation first, second, third for y2, first approximation, second approximation, third approximation by taking average of slope one by one. And whenever two approximation give same value, so that will be the final value of y2 and we can get the value y2. Similarly, in each interval we will take approximation for first interval for y1, second interval for y2, third interval for y3. We will find approximation value for this and this. That will be our answer. Okay, so modified Euler method gives the more accurate approximation to the value of y by using the formula. What is the formula? Just write formula. But in place of slope, we use average of slope up to consecutive tangents. So value we can write in general m plus 1 is equals to ym plus h by 2 average 1 by 2 h of, because our formula, Euler's formula is what? Y m equals to y m minus 1 plus h f what? X m minus 1 y. This is our Euler formula. Euler's formula. This is Euler's formula. In each interval, for first approximation of y1, here for y1, here for y2, here for y3, we use Euler's formula. For y1, if we have y1, then we have 0, here 0, here 0, we can use first approximation. For first approximation. For second approximation, use this formula by taking average of slope here and here. Clear? So ym plus 1 is equals to ym, just m plus 1, here m. Here m minus 1, 1 less. M plus 1, m, 1 less. Here, first value of f plus second. This is modified Euler formula. This is Euler's formula. This is modified Euler's formula. Euler's is this. This is Euler's formula. Clear? So, Euler's formula, modified Euler's formula is what? Here m plus 1, ym, h into half of means average of slope at here and here, at here and here. For this, for getting better approximation, we take average of slope of at here and here. At here 0 0, here 1 1 1 less. So here y xm ym. So here x m plus 1 and y m plus 1. Clear? So this is our formula for modified Euler's formula. Okay, and here this is previous approximation. Just okay? Previous approximation. It means what? This means just find from previous value. Just first approximation gives y, that is used for this. Means step by step, here, 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 here. If here y1 1, then this is used in this. And here 1 2, this is used in this. And this is y1 2, second approximation, this is used here. y1 third we will get, and this is used in next. So this is just previous value of y1, which we have already find through approximation in this interval. This process will do up to the approximation when two approximation gives same value in this interval. That will be the final value of previous value of y at as previous value. Okay, so in this formula, this is from previous. So here if we put m equals to 0, this is from Euler's formula, this is modified Euler's formula. Here in place of slope, this is slope, this is slope, slope. Divided by ds, slope, slope. Okay, for m minus 1, that is for y1, x0, y0, y2, x1, y1. So this is slope. For ym is for previous point. Here, just we see that this value can be found by using previous slope and this slope. We can get average slope and tangent nearer to this line, and we will get more accurate value of y as ym. Okay, so here this is modified Euler formula. So for each interval, first approximation of y we will find from Euler's formula, and then using this formula we will find second approximation, third approximation, fourth approximation. When two approximation gives same value, that will be our required value of y for targeted point. Clear? So these two formula are useful. For first approximation we will use this formula, and for further approximation we will use this Euler's modified Euler's formula. Here if we take m1 equals to 0, then we will get what? y1, m equals to 0. So y0 plus h by 2 f x 0 y 0 plus f x 1 y 1. This will be second approximation, because first approximation we will find from here. We will find from here first approximation for y, that is y1, m equals to 1, and first approximation. This is first approximation for y1 from this formula. So y m equals to 1, y1 is equals to what? m1. So y0 plus h f x0 y0. From this formula, we will get first approximation. And for second approximation, we will use formula, this formula. For y1, first approximation, y1, second approximation. Use this formula. Okay. Now, we can put the value here just from previous value. We can get this and y11, these values. Now, third approximation, we can get third approximation for y1, third approximation. Here, for third approximation, the value of what? Same value, y0 plus h by 2. Only changes will be where? Here. F x0 y0 plus f x1 y1 2. Just previous value you have to use. And similarly, for fourth approximation, in this place y1 3. Clear? So, this is our new value of, because first of all we have to find first approximation from Euler's formula, this first approximation. Second approximation give this value. Third approximation for y1, and just we will get approximation. When two approximation give same value, we stop the process, and that will be the value for y1. And this y1 will be used for next interval and doing same process for y2 and so on. This calculation can be done in a table very easily. This is a new value of y. So you can write new value of y is equals to what? Here, old value. For this interval, old value is this y0. For this interval, old value is y1. For this interval, old value is y2. Approximated value, best approximated value. So, old value of y. New value of y equals to old value of y plus h into mean slope. Mean slope. Just new value of y can be found by using this. And when two approximation gives same value, that will be the targeted value. Okay. Now, this calculation can be done by preparing a table also. Just take question, we can understand better it. Okay. So here just use this modified Euler's formula. Here, how many intervals will be there? Just it depends on the taking value of h. H is the interval of length of the interval. Okay, equal intervals. So, for understanding that, just consider on some questions. First of all, we take a questions for solving. So here, use modified Euler's method. Find y.2 and y.4 given that is here question. Solution. Given equation is dy upon dx equals to y plus e to the power x, y plus, and here y 0 equals to 0, I think. Okay, find, just we have to find y, find the value of y for x equals to 0.2 and 0.4. 0.2 and 0.4. That is y 0.2 we will find and y 0.4. Just this is our target. Just we have to find y 0.2, y 0.4. Okay. Now, in the given questions, maybe taking h equals to something in interval may be given or may not be given. Here nothing is given. So here initial value, here what, y equals to y0 means what, 0, and x equals to x0 means what, 0. This is x0 y0 means for x equal to 0 the value of y equal to 0, that is x0 equals to 0, y0 equals to 0. This is the initial point which lie on the curve of solution. Okay. So first value is what, this point, 0. Now second value, what, we can divide intervals from by taking the value of h, but here just we have to find the value at 0.2 and 0.4. Suppose like this. So this is one interval and this is one interval. In these two interval we can approximate, because our targeted value is y 0.2 or y 0.4. So here curve is starting from here and just here we have to find the value this, just we have to find the value this, corresponding to this y 0.2, corresponding to this y 0.4. Clear? So we have to find this value, that is, if this is x0, this is x1, this is x2, that is this will be what, y1, this will be what, y2. So our work will be what, just approximate the value of y1 here. Clear? So here y1 first approximation, y2 y1 first second approximation, y1 third approximation, y1 fourth approximation. Just we have to approximate the value of y1 in this interval, and when two approximation are same value, then that will be the value of y1, that is value of y at x equal to 1, x1. And in this interval, just we have to find y2, first approximation y2, second approximation y2, third approximation, and so on. When two approximation gives same value, that will be the value of y for x equal to 2, that is for this, that is this value. Okay. So if there is nothing given, suppose find the value of point y 0.4 only given, and from starting we can use intervals just like this by dividing in equal part, and in each part we can approximate the value and go up to this point, because in each step just we take value of y from previous value. So if in this interval approximated value is y1, just use this from here, approximated value, best approximated value here, and If y2 is approximate value, then here used and here used, and finally we can get up to here. But here just we will do the process of approximation of y1 and y2, not by further divided the interval. Okay, so here we can draw a table, because same type of process we will carry for the getting approximation. So here just prepare the table just like this. Suppose first value is value for x. Here this second value is for previous slope. Okay, and mean slope is this. We can draw the table for calculation. Okay, so here just our interval is 0 to 0.2, 0.2 to 0.4, taking h equals to 0.2, because 0 to 0.2 to 0.4, or 0.4 minus 0 upon 2 equals to what? 2 portion are there, 0 to this and to this, 1 2 part, so divided by 2. So 0.4 minus 0 equals to, this is 0.4 minus 0 by 2 equals to what? 0.2. So h equals to 0.2. Taking h equals to 0.2, our target is what? Finding the value of y 0.2 and y 0.4. For this, just find y x1 and y at x2. That is what? This is y1, this is y2. This will be our target. Clear? So here the value of x and slope, because first approximation can get from Euler's formula. First approximation of y, first approximation of y at x equals to, here 0, 0.2, 0.4 at 0.2. What? This will get from Euler's formula. First approximation of y using Euler's formula, using Euler's formula. First approximation in each interval, we use Euler's formula. So Euler's formula, y1 equals to what? y0 plus h into f of x0 y0. Clear? So here first value 0 0 both. So here 0 plus h 0.2 into fx0 y0. This is fxy. This means fxy. This is fxy. This fxy. Okay, fxy means, this means what? Y0 plus y plus e to the power x. So y0 plus e to the power x0. So here we see that 0 plus 0.2 into this y0. Y0 means 0. 0 plus e to the power 0. That is what? 1.2. So y1, first approximation is 0.2 of y1. Okay, so this can be written here as the first value of x. First value of x is x0. So we can write here 0.0. 0 means 0.0. Okay. And second value is for slope. Slope is this fxy. Slope is this. Clear? This means y dash. So here y plus e to the power x. This. That is what? Y dash. Y dash means slope. So here for this first stage, here nothing is there. Okay? No. Here is 0. Y equals to 0 for first stage. This is in this stage. 1. 0 plus 1. Clear? Here what we will write? Just like 1. From this formula, this is equals to y0 plus e to the power 0, 1. So this slope, and here just we will write mean slope. Mean slope. At first stage, at the first point, there is no mean slope. Because in the first stage we use Euler's formula. And from the second approximation we will use modified Euler's formula. Then we will require what? Mean slope, average of slope. So first stage nothing here. Now y, old value of y, just like this. We know old y is equals to what? Plus h, mean slope, is equals to new y. That is our formula, na? What is the formula? Y m plus 1 equals to y m plus h by 2. So sorry, h by 2 here. Mean slope. So mean slope h by 2. H by 2 means what? The 1 by 2 slope. Here f x m y m plus f x m plus 1 y m plus 1 here. This is our modified Euler's formula. Modified Euler's formula. Modified Euler formula for second approximation. Second approximation of y1. Of y1. We will use this. Put m equals to 0. We get y1. Second approximation. For second approximation, we use this formula. So m equals to 0, y 0 plus h by 2, or by 2 here, you can write here h only. First slope means what? Previous. Just previous slope. This. Plus fx 0, not 0. So here 1 and y 1. This way. From here we can get m equals to 0, y1, 0, 0, 0, 0, 0, 0. Y, x0, y0. This is at 0, 0. x0, y0, x equal to 0, x0. So y0 equals to 0 plus e to the power 0, 1, this. First test is, so this is the value of this plus this. This is getting by taking this value of y, just previous value of y. Okay? You can use this value here and we can get this value in table from this part, because second approximation for this we have to write here what? For the value of 0.2, always in this formula, just we can see that always y0 is written here. Clear? Always. But the value x1, here value is x1. The value of x1. x1. And y1 first approximation from here. So, x1, here the value of y comes from previous value, and value of y, value of x is 0.2 and value of y is comes from previous value, that is 0.2. So here we will write what? This previous value 0.2 plus y, because second approximation, first approximation is here. Here the value old y is what? 0. Old y is 0 plus h equals to 0.2 into mean slope is nothing here. This 1. This is the new value of y. This first test is 0.2. This value can get here 0.2. This is new value. This is y1 first test is. This is y1 first value. Clear? And now this value comes to here, that is here, first slope. In this second, first slope is here. So this we can write e to the power 0.2. It can be calculated. Just calculate by using calculator. So 1.4214. 1.4214. Just use calculator. You can find the value of e to the power 0.2 plus 0.2. You will get this. This is slope at the second approximation. First time taking slope at the point when we will get this value, only this value, x1, y1. y1 first time getting value y1. Just like in the diagram, what we will do like this. This is 0, this is x1, y1. First value getting this. And here x1, y1. This is x1, y1. Here slope. is this, and previous slope is this. So 1 plus this by 2 mean slope. So mean slope is what? 1 by 2 of 1 plus, because in this formula we can see that just we use previous value of y, that is previous value of y means this is comes from here, just we will get y1 second approximation, this value will be used in the next step y1 third approximation, just here y1 2 second, and remaining thing is same y0, just we can see use this repeatedly. Clear? So we can get this plus h into, and just this is different. So we can calculate average, this means 1. And further is also fx0 y0. This plus this by 2, this plus this by 2, this plus this by 2, and so on. So in table we can write 1 plus this 1.4214. This plus this by 2 is equals to, it can be solved also. 1.4214 equals to 2107. 1.2107. Clear? And here old y. What is old y? Old y is this. Because just previous value we will use here. Old y, previous value, first value is used. So old y, no, sorry, old y means this, always this. So same value in the first interval, here y0, all the approximation. So this y0 means 0 plus h means 0.2. Mean slope is this 1.2107. 1.2107. That is what? This portion. H into this portion. H into this portion. And this first value y0, 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 y0. So in table we can calculate this. Okay? Just calculate it. You can get the value 2107 into 0.2, 2421. 2421. This is what? y1 second approximation. This value. Now in the next formula, this value is used. That is here also. For 0.2, for calculation is here. Just we will do and tangent will be here. So also find third approximation for y1. So for 0.2 here, y, here y in this comes from where? This value. Okay? From where? Y comes from previous value. Just like 0.2 comes here, just this will come here for y. 0.2421 plus e to the power 0.2 for this point. Okay, initial point. Clear? Now this is equals to, can be solved 1.4635. 1.4635. This is by calculating, just calculate it. Now average of here see formula x0 y0 carry over. So that is first one plus just with the value of recent y, that is this value. this value, this slope. So this plus this, 1 plus this, 1 plus 1.4635, and this is equals to what? 1.2317. 1.2317. This plus this by this. This is mean slope. Now this mean slope is used here for getting y1 third approximation, because this first value is this, by 2 is this value is comes from previous, using previous y and slope this, and this is equals to this. Now for approximation y0 is continue, so here 0 plus 0.2, here slope this 1.2317, 1.2317, this is equals to, this can be approximated as what? Just calculate it. 2463.2463. This is what? Y1 third approximation. Clear? This is third approximation. Just same. Now 0.2. Just this value, and this value. When two approximation gives same value, so 0.2, and again do it. Old y comes from here, this 0.2463 plus e to the power 0.2, again 0.2 at this stage. Okay, x, this will remain in same value, x1 will continue, and y will change from previous value. Clear? So here this is equals to, we can solve 1.4677, 1.4677, and now just half here also, what will be 1 plus this, so 1 plus 1.4677 is equals to, can be solved 1.2338, 1.2338, 1.2338. Just you have to calculate it by using calculator. Okay, this. Now, just y will carry, so 0 is same, plus h 0.2 into here. What will be the value? This means slope. There means slope 1.2338. Just calculate it. 2468. 0.2468. This is approximation y, fourth approximation. Okay, just 2463, 2468, and once again we have to do this. Just do once again 0.2. Same calculation. Y comes from previous value 0.2468. 0.2468 plus e to the power 0.2. You can calculate it 1.4682. 1.4682. Clear? And just for average 1 plus this, because x1 is same. So first value is same, and second value comes from previous. So here 1 plus this 1.4682, 1.4682. So this is equals to what? Just calculate 1.2341, 1.2341, and here 0 will continue, plus 0.2 into this slope 1.2341, 1.2341. This is equals to 0.2468. This is y fifth approximation. Clear? So first approximation comes from Euler's formula and remaining approximations comes from modified Euler's formula. Clear? So here we see that these two approximation gives same value. So since last two values are of y are equal, we take, okay, just you have to write here about this. Just you have to make table. We can make table for calculation. Okay, just like this. Okay. Since last two values of y are equal, so we take this value as a approximation for y1. That is y1 means what? Y at x1 means 0.2. So y at 0.2 is equals to this value, 0.2468. This is our first approximation, y 0.2. Okay. In single interval, just we have to approximate the values of y1 by using modified formula from second approximation. First approximation we will get from Euler's formula. Okay, this is for first interval. Same you have to do for next interval. For next interval, first value of y will be this value. Clear? So first approximation is this, and now further calculation is very similar to this. Just here first value of y, what we will, because in the first stage we will take first value of y as 0. How one is get? 0 plus y, 0 plus e to the power 0 is equals to 1. This is first. So first value is y, this. For the next interval, first value of y will be this value. Okay. So now for second, using Euler's formula for y2 means this for 0.4 for the next interval. We start from just two intervals are there, 0, x1, x2. Now this interval, this will be the first value. So here y2, then here what? y1. Okay, and here what will be the value? x1, y1 from first value. We can write the formula as what? x1, y1. y1 will be what? This value. Here, second part. Okay, so from here we can get the value of how? First approximation of y2, second step y1. What will be the value? First value of this 0.2468 plus h 0.2. This is means what? y1 plus e to the power x1. y1. y1. What is y1? y1 means y1 is this. For slope, we'll use previous slope, because previous stage. Here remember that for using Euler's formula, first value is y1 comes from this for the next stage, because here x, this is 0, this is x1, this is x2, this is for y2, for y1. So here y1 comes from this for point 1, this, plus for in this calculation we use slope. Slope, how can we get the slope? From previous value, this, plus e to the power 0.2, this will be the value. Just you can use this value here. Just also here you can write this 0.2468 plus e to the power 0.2. This value can be written. Just take previous slope. So here you can write at the first stage. You can write. Just take it here. So for second stage, here x1 equals to 0.2. So this is 0.2 and this will be 0.4, 0.4, 0.4 and 0.4. And our calculation will just carry same process. Same process with different value. Here table is same. What will be the value here? Previous value of y, this 0.2468, 2468 plus e to the power 0.2, because previous value just starting point, Euler's formula. So x is this. Now 4 start, because for the first point, Euler's formula. So this and slope of here, just wait, 2468 plus e to the power 0.2. Now you can calculate it value. Okay, this is equals to, just calculate it. Just previous, in the previous table it is present 1.4682. 1.4682. 1.468. Clear? Here will be dash to first value by using Euler's formula. So this, and here old y means what? Or old y is this 2468, because just previous value is y. Okay, so here 0.2468 plus h 0.2. Slope, mean slope is this here 1.4682. 1.4682 is equals to, just calculate it, you can get 5404. 5404. This is what? Y2 first approximation by Euler's formula. Now just carry the formula. Just same process for 0.4. So here what? Y is this. So 0.5404 plus e to the power 0.4. 0.4. This can be calculated 2.0322. 2.0322. Just use calculator, you can get the value. Now average of this slope, this plus this by 2, this plus this by 2, this plus this by 2, here 1, 1, 1, 1, carry here. So at here, there, just 2, 4, 6, 8 is carry over. 2, 4, 6, 8 is carry over. And here, for getting slope, just here, half of this 1.4682 plus this 2.0322, 1.7502, 1.7502. Just calculate it. Add and divide by 2. You can get like this. Now here, in the second stage, y1 is continue. So always y1, this will continue. So 0.2468 plus 0.2. This is common, and only just write mean slope 1.7502. This can be calculated, and its value just like 5968, 0.5968. This is what? Y2, second approximation by Euler's modified formula, because using mean slope is there. Now same process here, y, previous y, just take this 0.5968 plus e to the power 0.4. This previous slope. This can be solved. Just you have to use calculator, okay? 2.0887. 2.0887. And here, this plus this by 2, because this is continue. Previous slope will continue 1, 1, 1, 1. So this 1.4682 plus this 2.0887. This can be calculated 7784, 1.7784. Now here this is continue 2468 plus 0.2. This is common. Here use this slope 1.7784. This can be calculated 6025. 0.6025. Clear? This is what? Third approximation. Now for next stage, y, previous value of y, 0.06025 plus e to the power 0.4. It can be calculated like 2.0943. 2.0943. Now half of what? Half of, just use this plus this by 2. So 1.4682 plus 2.0943. So this is equals to what? 1.7815. 1.7815. Now here common value 2468 plus 0.2 into this slope 1.7815 is equals to, you can calculate it, 125. It can be calculated, you can calculate it 0.6030. 0.6030. This is what? Y, fourth approximation. This is fourth approximation. Similarly, fifth and sixth approximation, just we are going on this process for getting same value of y. Okay, just do it and you can see the value can be get here. For next step, again use this value 0.6030 plus e to the power 0.4. This can be calculated 0949, 2.0949, and here half of this what? This plus this by 2. So 1.4682 plus 2.0949. This can be calculated as 1.7815. 1.7815. Here common value 2468 plus 0.2, 1.7815. This can be calculated 6031. 0.6031. This is what? Y2 fifth approximation. Now 6030, 6031, and once again okay, so calculate. We can carry over this process by using modified formula, just like same process up to the stage where up to the desired accuracy of the decimal places, just same value for same value. Just repeat this process also. 0.6031 plus e to the power 0.4 equals to, it can be solved 2.0949. 2.0949. Here also half of this. What? This plus this by 2. So 1.46, 1.4682 plus 2.0949 by 2. This can be calculated 1.7815. 7816. 7816, and here same value 2468 plus 0.2 into this 1.7816. This is equals to 0.6031. This is y2 sixth approximation. So here we see that last two approximation y sixth, fifth and sixth give same value. Since last two values of y are equal, so we take y at 0.4, y at all the values are y at 4, okay, is equals to 0.6030. Okay, so this y.4 is equals to this, and also y.2 is equals to 2468. In the previous section we have already got. So these are the what? At the first stage we use Euler's formula, and remaining stage, for remaining approximation we use Euler's modified formula. Okay, so by preparing this table you can get the value in each interval, okay, and it can be computerized because same type of process we will carry. Okay, now solve two questions, these two questions for your attendance. Okay, so by using one questions from Euler's formula and another question is from Euler's modified formula. Okay, so Euler modified formula, can be used for next approximation. But first approximation we will use what? Euler's formula. So these two questions you have to do and send me for your attendance. Okay, so use calculator for calculating the value. Okay, because this is numerical mathematics, calculator is very urgent for doing calculation fast, because just multiplication, addition, division is required for getting values at this stage. So use calculator always. Okay, so these two questions are for your attendance, you have to do. Okay, what or the process Euler method. What is Euler method? Euler's method formula is what? Just for question dy by dx equals to fxy. This slope, and here y equals to y0, x equals to initial value. This is initial value. For initial stage, just ym equals to ym minus 1 plus h. Use slope here x m minus 1 y m minus 1. This is the Euler's formula. Use this formula. Just carry over approximation. First approximation for y1, just previous first value is y0, second value y1. Here m equals to 1, then y1 equals to y0 plus h. H is what? H is for finding value, for required value. If required value is xn and starting value x0 given, up to this is divided. This is divided in n in sub intervals. Okay, so h can be find what? Xn minus x0 by n. This is the value of h. So you can use the value of h, and here f, if m equals to 1, then x0, y0. Just put the value in this function x0, y0, you can get the value of approximation of y1. And for y2, what? Here m equals to 2, then what? Here y1 plus h, f x1, y1. It can be found by using how? y1 will be used here, and x1 is for next test. Just what? Suppose 0, 1, 2, 3, 4. This is x1, this is x2, this is x3. So you can use this. You can get value. Similarly, y3 for m equals to 3, y3 equals to y2 plus h, f what? x2, y2. This is y2 is used here, and x2 is second stage. So you can put here in this function. You can get these approximately equal value of from this to approximation. We can write the result for y for that part. This is the value. Okay, when two approximation give nearly same value. This is the Euler's method. Very simple. Here it is depend how many calculations are there on the value of h. Okay, in how many parts we have to break it. Now Euler's modify formula. For Euler's modify formula, this is Euler's formula. First, this is Euler's formula. Okay, and modified Euler's formula. For modified Euler's formula is what? Just ym plus 1 for the next approximation in an interval. First approximation is taking from this formula, and remaining approximation in an interval for value of y, we use this from second to up to the required step, up to the required step of approximation. Ym equals to ym plus h by 2, average of slope, current slope and previous slope. This formula will be what? F xm ym plus f xm plus 1 ym plus 1 from previous value of y. We take the value of h from previous part. Okay, just this is the formula for here. For from second approximation, we use this formula, Euler's modified formula. First approximation is getting from here. And second approximation for third approximation, just getting you by using this formula. M equals to 0, then y1 2 this what y0 plus h by 2 here f x0 y0 plus f x1 y1 1, just taking previous value of y here, and these are remaining same, and get approximation. And when two approximation gives same value, that will the result for y, for the targeted value of x. Okay, so by using this method, just solve these two questions and send me for your attendance. Okay.